Okay, let's assume we have to compute this limit, right? All right, what would do first? We would do this 1 minus sine 0, because I mean we are just trying, right? Okay, how much is sine of 0? That's a sine of 0 is a 0. What is cosine of 0? That's a 1, right? So this becomes a 1. Sir, go ahead. You have a question? I one second. Right. I'll get this thing out. Okay. So the limit is 1, right? On the other hand, say I am asking you for say this. Say I gave you 1 minus cosine x divided by x, right? Now what happens is it becomes 1 minus cosine of 0, right? Divided by who? 0, right? So what we have here is 1 minus 1 over 0, and this is in 0 over 0 form. You're with me, right? Makes sense? Now, a way to handle these forms, as as you can see proven in our in our documents, okay, is this, that see, if I have this, that this is this.
So yeah. The first one is the answer?
In the first one is the answer, yes. That behaved well, one is our answer. Okay. This is the answer, yes ma'am. Just like you did algebra of limits, right? Remember very first thing in calculus 1, right? That is, if I have, see, I have a function whose limit exists here. I have a function here whose limit exists at the point of interest and is non-zero, right?
Oh, so you're looking for...
So first I look for this. First I will...
For a function that has a limit that exists at the point of interest.
Of course. Well, yeah, if it doesn't exist, then we are out of luck here, okay? All right?
So so the value should not be 0.
0 over 0. If it's 0 divided by a non-zero number, that's okay. For instance, if I had, say, this, e to the x here. All right? See this here? This becomes what? Excuse me, 1 over e to the 0 is how much? Is 1, right? So I get 0 over 1. 0 over a non-zero number is how much? That's a 0. That's the answer, right?
Right.
Makes sense? We are stuck only where? Right here in this case, right? Because here I have an indeterminate form, right?
Okay, so if you plug it in first, before finding... Oh, so you plug it in first and see if you have a 0 over 0. If it's 0 over 0, then you have to do... So if it was 1 over 0, it's just 1.
1 over 0 would be what? It'll go to positive infinity, negative infinity, depending on how we take it. I'll show you an example, all right?
Then that's also a problem.
That's a problem, but that one we cannot handle. I mean, that either goes up beyond limit or goes down beyond control, right? Okay, good. So here, let's look at this guy now. So in this case, what we will do? We will apply L'Hopital, right? The rule that you saw in the
notes.
Very good. So what does L'Hopital say? That if both the functions are differentiable at that point, right? Okay, all right. Then go ahead and take their derivative, not the quotient rule, just separately, right? Am I clear? See, this superscript stands for derivative.
What do you mean? What's differentiate?
Differentiate means I'm taking its derivative with respect to x, right?
Okay.
What's the derivative of 1 with respect to x? Tell me. Derivative of a constant with respect to x.
Is it just 1?
1 doesn't change. Derivative is the rate of change, right?
Right.
So 1 doesn't change, so the derivative is 0, isn't it, right? Are we good on this? See, 1, the derivative of 1 is what?
0.
0, because 1 is a constant, right? Derivative of a constant function is 0, isn't it, right?
Right.
Okay, so here we have a 0. I know it's late in the afternoon, it's storm
No.
outside.
It's been a while since I
It's
took the
okay,
first
so
sentence.
it will become non-while very soon, okay? Now I'm differentiating cosine x. Tell me, what do you remember from a while ago, very quickly?
The sine of x.
Just
Negative sine of x.
very good. See, we did good, didn't we, right? What's the derivative of x?
1.
Very nice. See, you're doing so good, right?
That's what 1 is. It's just
No. I mean, what was then? I mean, you know, derivative of sine, cosine.
cosine.
No, derivative of x is 1, right? Oops. You are a little excited here, right? So then we got this, right? And then I have simply what? Negative of negative would be positive sine x, right? Divided by how much? 1. Who is sine x as x goes to 0? 0, right, isn't it?
Sine of 0.
Yeah, right. Divided by 1. That means the limit is 0, right? Am I making sense? Okay. Let me give you something to try. Alright, give me a moment. Let me make another exercise for you that you can just try. Alright? Okay. So why?
So good question.
Ask
So
me.
the derivative of sine of x is cosine x.
Right.
But the derivative of cosine x is negative sine x.
Yes.
Okay.
That was a while ago, but make sure you understand the reason. Alright? Okay. So here, let me give you a different question. Okay. Alright. Here. This time I'm going to let x go to say pi over 2. Alright. And then I have x goes to pi over 2, right? Okay. And then I got 1 minus sine x. Is that here? Oops, sorry about that. Divided by cosine x. Could you do this for me? Just try it on your own, all right? And we will look at it in a minute, okay? The class. Okay. So here, so this becomes in 1 minus 1 over 0 form, right? Are we good here? Which of course is 0 over 0, right?
Right.
Okay, so what I will do now is we'll try differentiating, right? That is using L'Hopital. Okay. All right. So use this here. Derivative of 1 is
0.
That of sine x is
Cosine
cosine x, and here it is
negative sine.
right. Are we good?
We're good.
So that is
becomes negative.
that is negative 0
Negative 0.
over negative 1. Not really much more interesting. It becomes a 0 again, right? 0 over 1 is 0, right? Now let's just let me think of something different. Okay, so one moment. Okay. All right, here is limit as x goes to 0. Okay, all right, take it, that's all right. So 1 minus, you can take it. I mean, I have no problems with that.
Yeah, this is what's nice.
So this is, yeah, go ahead.
That'll be, okay, well, 2 times 0 is 0.
It's 1 minus
1.
e to the 0 is 1. Yeah, oh, very good. Divided by 0. Again, you must be getting bored of it, right?
No, I'm not.
Okay. Okay, so it's 0 over 0 form again, right? So let's try it over. It will bring some good old memories back. Okay. So here we are going to differentiate it, right? Okay, so let's do it. Here, derivative of 1 is what? 0. E to the 2x.
Does it have to do with n?
Okay, now keep this in mind. This has to stay in front of my desk, all right, until it becomes a second nature for me, just like I'm driving somewhere and I don't need directions. I'm just, all right. When I have derivative of exponential, remember? E to the x was the easiest function to differentiate, wasn't it, Rosman? Okay. I'm sorry, I said, you don't mind me saying your name, right? Okay. So this is what it is, right? Remember that?
No.
Okay, you don't remember it? Remember it now, right? Okay. So if I apply that on this guy here, okay, that is I want to take d over dx of this. Okay, here. I'm going to do the easy one here. How much is that? Don't tell me. I want to do it myself. It's a 1, right? No? Derivative of x is 1. Now see, if u is a differentiable function of x, right? Are you with me? Then derivative of e to the u is what? E to the u times derivative of u. That was the chain rule, right? Okay, if you don't remember it, just take it now and you know the lecture that I have posted on exponentials and logarithms, okay? In that I have written detailed proof, okay? All right, but don't worry. See, derivative of e to the x is how much? E to the x, all right? So e to the x is a function, right? Which grows as fast as its own value, right? Okay, that's the rate. Now, if I have u instead of x, right?
Right.
And u is a differentiable function of x, then this is what they remember. There used to be something you did as called chain rule, right?
Right.
So chain rule tells me this, right? Because you know derivative of a composition of two functions is product of the derivatives. Okay. So anyways, let's keep this as a rule for now. All right. Okay. So this would be what then? Limit as x goes to where? 0, right? When we have, okay, tell me what we'll have upstairs now. Use this, okay? Don't do that. See, who is u here?
2x.
2x. What should I write there? E to the, who is u?
2x.
2x. Yes, why do you look puzzled on this? All right, so here. So I got e to the 2x. Are you fine on this? Right? I'm just using this rule. Let's not, at the moment, right? Now I have, oops, sorry about that. Now I have to do what? Write the derivative of 2x, right? Makes sense?
Right, yeah.
Who is the derivative of 2x?
2.
Plain and simple, 2. Very nice, right? Are we good?
Yeah.
Now give me the limit quickly. Negative e to the 0, right?
Right, because that goes to 0. Okay.
1. And how much is this?
So negative 2.
Very good, right? Okay. All right. So we will get on to business right today. All right. Okay, and that will help us a lot. Okay.
It is helpful.
It will. Yeah. We see. We did very good, didn't we? Right. Right. So here, instead of here, I have e to the negative x, and then I have to differentiate it with respect to x, right? So what I do here is I use the substitution rule. Okay. That is what I would do is I need a u here, right? So I'll say, okay, I'll take negative x as what? U, right? Makes sense? Okay. And then I need this differential expressed in terms of differential of u, right? So if I take differentials of both the sides, the left hand side is this and the right hand side is that, right? So that changes what? That changes the right hand side to negative du, right? Make sense? Good. So I have to compute this, right? See that? So e to the negative x is, this is u, right? And this part is who? Negative du, right? Isn't it? What does this become according to this? E to the u, so that's negative e to the u, right? Who is my u? U is, very good. So we got negative e to the negative x. Okay, all right. So now you said you did integration by parts, and we are using that on this example, right? So yeah, tell me, integration by parts told you what? U dv, yeah, keep
Equals
uh-huh,
UV
right?
minus
Oops, minus.
the sign.
Okay, integral. Don't say
Integral.
sign. No, integral. We have to,
Integral.
right. It should look like we did calculus too, right? And of course, this is kind of a sum, type of a thing, and that you will recall from good old memories of calculus one. Okay,
Right.
is that good? So who are we taking as x? X we are taking who? U. And who are we taking as dv? We are taking that as e to the negative x, right? Makes sense? Dx, of course, right?
Right.
Are we good? So this tells us that dx equals what? Du. And when I integrate these guys, left hand side would be v, right? And the right hand side would be this guy here, right? Are we good? So then you just did it. How much was it?
Negative e to the minus.
Negative x, right? And this thing is right there. I don't know why. That will disappear. Don't worry. Okay. So are we fine on this?
Yes.
Right? So according to this, this is going to become equals u is x, right? V is negative e to the negative x, right? Make sense? Minus, okay, so we have v du, right? So v is this thing here, right? Am I making sense?
Yes.
And then this is dx, okay? All right. Okay, so then we have this, right? This changes to what? Plus. Are you clear? Because when I pull this negative sign out, negative will be positive, right? So this becomes what then? Negative x, right? E to the negative x, right? Then again minus e to the what? Negative x, right? Because this is who that is. We just did it, right?
Are you doing u minus b?
Just as I'm doing this part here. See, this part is uv. Let me write it like this. Actually, we are getting close to that 435 limit, so I am just getting you in panic mode. Let me not do that. Okay. All right. Here we're good, right? See, I did this. uv. So I have u, and then I have this v, right? Minus integral v du, right? Are we clear? Then what happens is this multiplies as that.
Bring it out. Okay.
I brought it out, right? Then it stays as that, and this value, as I just did here, right?
You have to take the answer derivative. Okay.
Again, of course, you can write plus a c, right? Okay. Now let's do this here first of all. Since let me just tell you,
So dx goes to
dx goes no way. Oh, this is just a symbol. All right. That is, see this here. whenever we have this, that say df over dx, where f is a function of x, right, equals say big of x, f of x, right? So whenever we have this thing, right,
Yes.
what we do is we say, okay, the antiderivative of this big F, and that's the symbol for antiderivative, okay, with respect to x, again, is symbolic, right, equals who? Little f, right? Am I making sense?
Yes.
So that's how this came out to be, okay? Now, let's do something so that in our...
So when you're solving everything, you have to keep the dx there, even though it's symbolic?
Is when you take the integral, see, I have not taken the integral yet, right?
Oh, so it has to stay there.
Of course, I've taken the integral, okay, unless you become really informal with that later on, okay? All right, is that good?
Yes.
Good. So now, yeah, now, I mean, we haven't done the indeterminate forms yet, okay? But it doesn't look like that I'll be able to do it within 4:45 later. So let me first tell you something. First of all, look at indeterminate forms here, okay? And the other thing is, I'll send you to this link. I mean, I'll send you this link. That's where my videos are. This is www. And I'm not sponsoring any videos. Okay, it's just like a non-monetized account. Okay,
Right.
so you can skip the advertisements. All right. So see this here. So here, let's look. If I have an, there is an antiderivative video. You said you forgot antiderivatives, right?
That will help.
Okay, so make sure you, because this does everything from scratch. All right, makes sense. Okay, so that's it. And it's like a full class, like it's about 50 minutes. Okay, all right, then let's keep going. Quadratic, I think I had done lots of them. One moment. Okay.
So to submit the quiz, we do it on paper and then
You can scan it, right? Now, could you keep watching with me if there is anything like indeterminate forms showing up, so that because yeah, you got that pretty good. What was that? Uh, integration by parts, right? Okay. Posting. Okay. So here, all right. I have to. I know I'm going to organize them all on my website, but just give me a few seconds. I'm just saying, and here